how do you know how many minutes of angle or how many mils you need to hold over? So let's say we're looking at coyote number 1. We're gonna identify our shooting conditions. There's one piece of technology that long-range shooters don't talk about, and I think is really a game changer for people like me. Today, I want to be talking about BDC versus MRAD or MOA scope reticles, and I'll be going out to the range to put those two ideologies to the test. I'll also be going over the general how to utilize BDC, MRAD, etc., and why I think BDC is way better. Okay, today we're going to be talking about BDC versus MRAD and MOA. We're also going to be talking about how to account for bullet trajectory in general, what that really means, BDC, MRAD, or MOA, the right kind of shooting aids, dope cards and target sizes, windage elevation, general size cards, things like that. I have a limited memory, so I have a picture of a goldfish there. And I have tons of other hobbies that I want to be proficient at. And so I don't have a lot of the time to sink into long range shooting to remember all these minute details. And so I think I found a way to really condense all of that into one single card or something I can review very quickly to get back up to speed on when I want to go shooting. The general process of taking a shot, we're going to identify our shooting conditions. We're going to sight up and take the shot. When you're identifying your shooting conditions, we're talking about how far your target is to the range, and then we're also talking about the environmental conditions. So that could be anything from temperature to humidity to wind and more. We'll talk about that later. Secondly, the sighting up, we're going to get our aim point on the target. And that isn't always the crosshairs of your scope, depending on how you're doing things. And then lastly, of course, we're going to take a shot. So really quickly, just a general overview. When you shoot anything, any kind of trajectory, it follows a roughly parabolic path. Drag from air resistance makes it not exactly quadratic, but in general, how we're going to account for that is by angling your gun up. And so we could angle it in degrees, and we could say, hey, angle 1 degree, or realistically, we're going to say angle 0.1 degrees. And since these angles are so small, we use other units of measure to measure that. It's kind of like using millimeters versus inches. And so you might hear the term milliradians or milliradians or mils. You also might hear MOA, or otherwise known as minutes of angle. These are both just two different ways to measure an angle. Generally, the US military now uses mils, and a lot of old school hunters, long range shooters will use MOA or minutes of angle. And your scope will be measured in MOA or mils, and that's how you can determine what you should use. Now, not only do you need to angle up and down for elevation for the bullet drop, you might need to angle left or right, for example, for wind impact for the bullet. So at any specific range, you're going to be able to say, hey, at 100 yards or at 200 yards or at 300 yards, I need to hold 1.7 mils, or maybe it's 3 minutes of angle, or MOA. So how do you know that information? How do you know how many minutes of angle or how many mils you need to hold over? Well, you can use what's called an empirical data. So that would be just real world experience. You go out to the shooting range and you shoot a bunch of times, and you see that without touching your scope or anything, at 300 yards, the bullet drops a certain amount of angle. The easier way is to use a ballistic calculator. There are lots of high fidelity ballistic calculators available for free on app stores now. Often you'll have to pay to get these super high fidelity effects, such as Coriolis effect or things like that. But those are so minute at any range less than 1,000 yards that you really don't need to worry about it. Okay, next, this is what you would create from your ballistic calculator or from your empirical data. And this is called a dope card, or data of previous engagement. And so in general, we'll kind of look to the top right here. You would say, okay, for my specific ammo that I'm using, and you have details like your altitude or temperature, humidity, whatever information you want to include in there, because those are all going to affect your trajectory slightly. Then you have your ranges. So at 1,000 yards, I need to go up 0. That means this person's scope is sighted in at 100 yards. It may be in a 10 mile an hour wind, I need to account for 0.2. This could be mils or MOA. You just need to write up here in the headers which one you're using so you know for the future. I happen to use mils. This is a very simplistic version, so all you have is how much you need to come up, and then in a 10 mile an hour wind, there's going to be that much drift. That's going to be your left and right, or your windage. Here's a more complicated one, and this is a very awesome one I pulled offline from a forum. And it's very complicated, but this has your bullet drop. You can write it in mils or radians, or I'm sorry, mils or MOA if you'd like. You'd fill it in for your rifle using the ballistic calculator outputs. You have how much you need to compensate for the wind, for 10 mile an hour wind at each range. It also has how many mils 10 inches is at each range. Don't worry about that if that's confusing. It's a lot of information. This one is super helpful, but I would say more for advanced users. You can hit targets very far out without using something as complicated as this. Okay, so very simplistically, here's what that would look like. If you have your dope set up in your app, or maybe you've written it down on a note card, I would highly recommend that so you're not always reliant on a phone battery. And you see your target at 300 yards. How do you know that's 300 yards? We'll talk about that in a moment, but let's just say we know it's 300 yards. Maybe you're at our shooting range, and so you know. Well, you need to account for 1.2 mils in this case. And let's say there's a 5 mile an hour wind, so this is 10, so we're actually going to half this and go 0.25. And that wind is, we're saying it's coming from the right of the shooter going left. So I would just count down to, what did I say, 1.2 mils. So we go 1.2 is going to be this first notch here, center of my cursor. That's where we'd line up for elevation. And then since there's 0.5 mils of, or I'm sorry, 0.25, I said there's a 5 mile an hour wind. Since there's a 0.25 mil holdover for the wind, and it's coming left to right, we're actually going to hold. There would be 1 mil, so 0.25. I'm sorry, this would be 1 mil. So somewhere in here, and that's where you'd shoot. Now, there's some obvious difficulties here. Where I'm holding my cursor, there is no dot, right? There's no way to really get exact. And so a lot of scopes will have turrets on the top that actually adjust your scope for mils or MOA. And so what you would do is you would dial, click, 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 click. So it would sound like you would dial 1.2 for the elevation and 0.5 for the wind, or 0.25 in this case, for the wind. And then that way you could actually hold the center of this reticle on the target. So that's how you would utilize the scope. Now there's something way easier than all of this, and that's called a BDC. So let's get to that now. Okay, so we've already discussed the scope here on the right. These are different measurements of mils, and we see maybe 1/10 of a mils here in this section after the 4. And that's used for ranging objects, and I'll get to that later. In the middle, we have a generic hunting scope. Now you might see the issue here. At very far distances, you have no idea how far to hold over or what angle to hold your gun at, which is why I think with the price point of modern scopes, there's no reason you shouldn't get a MOA or MRAD scope reticle, or maybe a BDC. So what is a BDC? BDC is bullet drop compensation. So remember that dope card where I said 300 yards is 1.2 mils? Well, somebody already did the math for me. So I buy this reticle, and that is specifically calibrated for my caliber. So I'm shooting 308 Winchester, and this actually would be the very first post here. Let's say 400 yards because it has numbers and that's easier to see. So let's say for 400 yards, I don't have to go look at my card and say 400 is 2 mils. I can simply go here. This is a 4. That means I'm going to hold it right here dead in the center. And that's how that would work. Oh, for 600 yards, I don't need to look at my reticle or I don't need to look at my dope card. I just know 600 yards is right here. So what are the limitations of this? Well, the BDC reticle was calibrated for a very specific firearm at a very specific temperature with a very specific ammunition. So the odds are it's not going to be this exact same setup that I'm using on my rifle. Now the question is, does that really matter? How far off is it going to be at 600 yards? And that's what I'm putting to the test today at the range. I'm going to try it at 300 yards, and I'll progressively each video get further and further. So this is the actual reticle that I use. It's a primary arms 4-14 by 44, long name, FFP scope with ACSS 308/223 HUD DMR. Yeah, a lot of words there. Something interesting about this scope though is that the bullet trajectories for 308 are very similar to 223, and so it actually works for both, which is very handy. So I could put the scope on my 308, or I could put it on an AR-15, and the scope, once it's sighted in, all of these pre-made measurements are going to work for those calibers pretty well. This reticle has a lot going on, and there's a ton of features, and I think this is really the bee's knees for people like me. My main hobby is not going to be long-range shooting, and I have plenty of other hobbies, but I want to be able to go out and hunt. I want to be able to be defensive at long range if I need to. And so once I make some cards maybe to remind me what each of these symbols mean for my scope reticle, I can pick this up a year later, look at that card and say, oh yeah, I can go out and shoot this, no problem. So now let me show you the first part of this workflow. Remember this general process I showed earlier? We're going to talk about this identifying shooting conditions now. But before we do that, I'm going to talk about the actual full process that we should go through when we take a shot. So before I talk about this, I have no military experience, but I'm a systems engineer and I really like flowcharts and things like this to get in my head to make sure I'm doing everything safely and efficiently. So the first thing I do is shooting safety. Before I can even look down my scope to look at a target or look at an area I might be shooting at, I need to understand, is it safe for me to do that? If I'm pointing a rifle somewhere, I need to make sure it's safe to do so. Next, I'm going to identify a target or the planned target area. Maybe you're hunting and you're going to take a shot if elk or deer walk down into a certain area. Once you know that, you can identify your shooting conditions. And we already talked about identifying shooting conditions includes range and environmental conditions. You're going to get on site. So once you identify your range and the wind and things like that, you're going to put whatever that aim point should be on your target. Whether it's going to be the crosshairs because you're using the turrets on top to adjust for your angle, or it's going to be maybe an offset in the reticle. Lastly, before we take a shot, we're going to check again our safety. We want to make sure that we're okay with destroying anything that is beyond our target or in front of our target, and then you'll take the shot. So I use memory tools for these two items here, identify your shooting conditions and sighting up. And let's talk about that. So when you're ranging, you can simply use a rangefinder, or you can actually use a BDC, ranging measurements inside it to determine the range of your target. I'll discuss how that works for my specific reticle in a minute. Next, here's your atmospheric conditions. And there's a lot here. There can be air temperature, humidity, wind, atmospheric pressure, cardinal direction from Coriolis effect, bore temperatures, spin drift, and more. So what really matters? I made this spreadsheet using data from a ballistic calculator that I actually ended up making for this project, and also data from the Hornady ballistic calculator app on my phone. So when we're talking about your horizontal effects, which are the hardest ones to account for, the wind effects trump everything. This is the horizontal drift in inches over distance here. So we see at 800 yards at, I think I put 5 mile an hour wind or less. We're looking at over an inch off. Of course, you also have to account for spin drift, aero jump, Coriolis effects, things like that. But those are going to be relatively small. They do stack, so really this, if I had all these other effects, it would be maybe closer to 2 inches or maybe even 2.5. But as you can see here, we can see that wind really trumps over everything else. And that's what you see experimentally, right? If you go out to the range and are shooting at 1,000 yards or watch videos of people shooting at 1,000 yards, they can use their ballistic calculators to account for the spin drift and the aero jump and all these things. But wind is still the major factor here. So what I would tell you is that for windage, ignore all things maybe up to 1,000 yards except for wind. Now for elevation, your bore temperature and the temperature of the air, and they can make a little bit of a difference. In general though, the colder the barrel, the lower your shot will be. This is a picture of the orbital perturbations versus altitude, and that's what made me think to make this chart. It's just good. It's really helpful to know what are your main effects that you need to worry about at, in this case, altitude, but in our case, shooting distance. Okay, now we're going to talk about ranging. So there's kind of two ways to do this. If you have mils or MOA measurements in your scope, you can actually determine the range of something by using two things. You have to know the actual size of the target and the actual formula used for this calculation. It's very simple. I'll put it on the screen maybe, or you can just look it up. Mils range formula or MOA range formula. It's very simple. So what you can do is you measure how many mils in your scope that object is. Let's say I measure in my scope a deer's head and it is 0.1 mil. Well, I know a deer's head is 10 inches on average. And so using 10 inches and 0.1 mil, I can plug it into my formula and get the distance. Where that gets a little bit difficult is that you have to look down at a calculator to punch all this in. You can have some information like this in your dope card as well. So I see here on this far right column, I have 0.7. So let's say I measure a person's head or a deer's head, which is both about 10 inches, at 0.7 mils in my reticle, my scope reticle. I know just by looking at this guy, well, it's between 375 and 425 yards. And so that's how you can determine the distance of your target. Now, if you have a BDC, like the one I have here, it gets a lot easier. You don't have to look down at your calculator or at your dope card at all. I'll show you how that works now. This particular BDC has three measurements. It has a 36-inch measurement, an 18-inch measurement, and a 10-inch measurement. It just so happens that the average deer shoulder is 36 inches tall, and the average width of a deer is 18 inches wide. Similarly, the average deer head is 10 inches. Now for a coyote, the torso is 10 inches and the length is 18 inches. I put this in here for an elk. The average torso for like a trophy elk would be 36 to 40 inches. And for a man-sized target, the average belt to tip of the head here is 36 inches. And then your shoulders are about 18 inches apart. Similarly, a person's head is about 10 inches. And so what this means is you can use all of these little reticle symbols here to get your range. Let me explain. Okay, so I have my fake reticle in here. I made it red now. So let's say we're looking at coyote number 1. I want to shoot this coyote number 1. Well, how far away is that coyote? I happen to know this coyote has a torso of about 10 inches. That's the average size for a coyote torso, as I mentioned earlier. And this 10-inch ring right here lines up pretty perfectly with the torso of that coyote. I happen to know that this bar, if we're counting here, if you can see these white numbers are kind of hard to see against this background, but you have a 4 and a 6. And so this would be 100 yards, 300 yards, 400 yards, 500 yards, 600 yards. So if it lines up perfectly on that coyote there, as you see, number 1, I can go to this 300 yard marker and take the shot right there. Would be a kill shot. Now, what if there's wind? It's a great question. So coyote number 2 in the purple here, I'm gonna line him up. Wow, he's really far away. So it looks like this circle here at the 600 yard mark lines up with him. So if there's zero wind, I line him up right there and take the shot around this crosshair. Now, if there's wind, this BDC has built-in wind measurements. And so these dots off to this left and right here, or I'm sorry, to the left, is a 5 mile an hour wind and a 10 mile an hour wind. So let's say there's a 10 mile an hour wind. That's very difficult to account for at 600 yards. Well, with this calculation, pre-made calculation here, I can simply hold it there, take the shot, and that should be good. This BDC also has measurements for moving targets. So going back to the 600 yard here, let's look at this coyote again. So average walking speed for a person is just going to be this first dot. The average jogging speed would be a second dot here. And then the sprinting speed would be this circle. So if this coyote was at a trot, maybe I'd hold it right there, or maybe I'd go maybe in between a jog and a walk. So right around there. So that's a 600 yard shot accounting for a moving target. And what is cool here is that if there's wind on top of this, you can kind of look here and estimate, okay, how far that is for a 5 mile an hour wind. I'm just gonna add that to my holdover. then that's where I take a shot. Having a BDC reticle is a great equalizer for people like me who go out to shoot occasionally, maybe several times a year, and someone that shoots full-time as their profession. If you can, gentlemen, always start out your day by serving your wife some way. Unloading dishwasher, laundry, whatever it might be. Okay, so this is the target from the 300 range test. So this first grouping here was the first shots I took. That is from the BDC, so the bullet drop compensator. This is the first shot, this is the second shot, and then these are the third and fourth shot. These are going to be the cold bore shots, you know, for cold bore specifically being this one, the first one. That might explain why they are lower. So kind of the total spread here is about 6 1/4 from center to center. Of course, I was aiming for center. Now, when I dialed in the turrets on top using mil-radians, this is the grouping I got. I was aiming for this target here. So of course, when I'm doing that, I'm able to utilize the actual chevron there in the center. Yeah, so that's about a 3 1/4 inch grouping. It's hard to say if these were due to the cold bore or just me getting warmed up as well. So I took 2 more shots using the BDC at this target here. We're looking at a 4-inch spread. I guess what's also important is to look at, you know, from the actual center point where I was aiming at. Looks like a maximum of 2.5 inches off. The first grouping, max offset, I guess I'll call it, about 5 1/4. Then for this guy, it looks like it's gonna be about 3.5 inches off. So it looks like using the turrets did result in better accuracy. The difference is so marginal, it's hard to say if it was really the BDC being off or just my shooting being off. All right, so there you have it, folks. It looks like at 300 yards, the difference between using the BDC in your scope and specifically calculated MRADs or MOA from Ballistic calculator to your rifle, the difference is marginal. We'll see how that holds out as we go further and further in each video. I expect it will drop off maybe 600 or 700 yards. We'll start seeing a big difference. Stay tuned to find out. Catch you in the next one. If you've enjoyed this video or the series, consider leaving a like and subscribing to our channel. You might like the other videos, go and check them out.